So this is the question in 2011, GATE 2011, question number 55. So it's a common kind of a question. Some common information is given, and from that question number 54 and 55 are framed. But we will be focusing on question number 55. The question information is that a plane electromagnetic wave has the magnetic field given by this, where we can see that B, which is a function of space and time, is equal to B naught k cap, because B naught is a constant vector. So B naught vector means B naught k cap, z direction, sine x plus y k by root 2. This is the wave information is given in this particular argument of the sine. So it is given, and all other things are known. K is the wave number, I, j, k are the Cartesian unit vectors in x, y, z directions respectively. The first question was that the electric field corresponding to the above wave is given by, so we need to calculate, because the second question is related, that is the average pointing vector is given by this. So we will be considering this particular question, question number 55, the average pointing vector. So B is given. Now we need to find out, first we will see that what is the pointing vector, what is the definition of the pointing vector, and then we will proceed to the question. So let's see the solution. Okay, so here which is given thing is that B is equal to B naught sine x plus y k by root 2 plus omega t. It is given in the question. Now we need to find out the average pointing vector. Now what is pointing vector? Pointing vector is defined like this. S is equal to E cross B by mu naught. We are considering a free space, so we are writing it as B by mu naught. Mu is equal to mu naught, and hence it is this definition. Now B is given. We need to find out what is the E, the electric field. So electric field, if it is found out, then we will put it in this particular expression and find out what is the S. After that we will average. So that is the later part. Now we already know that the relation between E naught and B naught in this way, if electromagnetic wave can be written in terms of electric field, then it is E is equal to E naught vector. This is the constant vector, E naught and B naught. Again I write E naught and B naught are constant vectors. So if we can write it like this, I have written plus omega t because it is here written as plus omega t. So E naught sine kx plus omega t, B is equal to B naught sine kx plus omega t. If this is the condition, then the relationship between E naught and B naught is actually given by E naught is equal to k cap cross C B naught. Now we have to be careful. This k cap is nothing but the propagation. This is the propagation vector unit, propagation unit vector. Unit vector. It has nothing to do with the z direction unit vector, that is k cap. So there will be a k cap here. So it has nothing to do with this k cap. This is the propagation unit vector. So let's find out what is the propagation vector. So k, the propagation vector, what is that? This is the propagation vector. From here, this information will tell us that what will be the propagation vector. So if we compare this particular expression as some k dot x plus omega t was given in the sine part. So if this is the thing, then we can write this as kxx plus kyy plus kzz. Now as it is given that x and y are there, x plus y is there, no z, z is equal to 0. So we are left with this particular expression. Now this, if we compare with kxx plus kyy, kxx plus kyy is equal to x plus y by root 2 into k, then we can surely, comparing x and y terms, we will get k by root 2 I cap plus j cap. This as the unit vector, because it is ultimately k dot x. So we can easily find out from here. Now what is the magnitude of this propagation vector? Is nothing but the scalar component in the I cap direction and the j cap direction. You just add it, square it, and we will get that as k. Therefore the propagation unit vector k cap is, as per the definition of the unit vector, it is the propagation vector to that of its magnitude. If we do that, it comes out to be I plus j by root 2. Now we know that B naught is given in the question, that it is equal to B naught k cap. Therefore we need to find out E, and for that E naught needs to be found out. For E naught needs to be found out, and E naught is given by this expression. So we calculate k cap cross C B naught, this particular thing here. So 1 by root 2, 1 by root 2, so whatever the cross product is, we calculate it, and ultimately we are getting E naught is equal to C B naught by root 2 I minus J. So we have found out E naught. Therefore, what is the electric field? It is given by this E naught sine kx plus omega t. Therefore, E will be equal to C B naught by root 2 I minus J sine x plus y k by root 2 plus omega t. This thing will not change because this is the EM waves, particularly the information carried by the EM waves. Only thing will change is this E naught if we are writing in terms of electric field and B naught in terms of magnetic field. That's all. So we have found out the electric field vector when the magnetic field is given in this way. Fine. Now the Poynting vector S, as I have defined, E cross B by mu naught. So E cross B needs to be found out. So we are just writing this, and the sign terms will just be squared because E also has sign. E naught sine this and B naught sine this. So sine square will automatically come out, and this E naught cross B naught will be the only vectorial product which will happen here. So this particular determinant which we have written is nothing but E naught cross B naught, because this is the vector which is present. These are nothing but the vector. This is not the vector. This is the scalar component, the sign part. So that's why it is just got squared out. Fine. Now this becomes the E naught cross B naught. When solve this cross product, we get this. I have written it as sine square phi instead of writing the whole expression, and I have defined phi is equal to x plus y k by root 2 plus omega t. Now this is the Poynting vector. Therefore, now if we need to find out the average Poynting vector, so we will be phase averaging it. If you doing the time average or you are doing the phase average, the things are same. So it will be minus c b naught square by root 2 mu naught I plus j, and this becomes sine square phi. So sine square phi has to be phase averaged. So 1 by 2 pi, 0 to 2 pi, sine square phi d phi. We write it as 1 minus cos 2 phi by 2. This is the trigonometric identity, and we get t phi. Solving this integral, we get only half because this term will be 0. 0 to 2 pi sine 2 phi by 2 is 0. Therefore, what we get is this particular expression. Therefore, average Poynting vector becomes minus c b naught square I plus j by 2 root 2 mu naught. From where this 2 is coming? From this particular averaging. So D is the correct option. If we see this expression, yeah, D minus c b naught square by 2 root 2 mu naught I plus j. This should be the correct option. Again, we look into it. Yes, this is the correct option. So given a magnetic field vector, we first have to calculate the electric field, which is nothing but the first question, which is here. We have already solved this question, and in this 55th question, we need to find out the average Poynting vector. So we take the definition of the Poynting vector, that is E cross B by mu naught, and calculate what is the Poynting vector, and then average. Averaging here means the phase averaging. Whether you do time averaging or phase averaging, the things are same. So it's better to do phase averaging because the integrals becomes easier. Okay, so that is the answer. So D is the correct option. Thank you.